In this video, we are going to write the equation for a piecewise function, and we are going to use Isaac's distance from home as a function of time as our example. A piecewise function is used to represent functions with varying rates of change, and it is comprised of pieces for which equations apply, but only for a particular part of the domain. And the further we get from the y-axis, you can see why we're going to want to use point-slope form for the equation for our lines. For each line, we need to find the slope, and we need to use a point. For this first piece of our function, we can see that our slope is -2/1. We have a point, or we can use our y-intercept, and we see that it applies between 0 and 0.5. So we show this as our slope is -2t plus 3, the y-intercept, over this interval of the domain. Each one of these will be listed as an expression because d of t equals is over here on our left. Next, we have a horizontal line at y equals 2, and this applies across this interval. So we have 2, and we show our interval of 0.5 to 2.5. Next, we have a slope of -1 divided by 1/2, which is -2. We find our interval, and so we can write our equation. We're definitely going to use point-slope form now, and so we substitute in our x value and our y value. We have another horizontal line. We find the correct interval, and then we find that our final piece has a slope of -3 over +1, and we substitute in the first point of that piece. And you can see that each interval, because this is a continuous function where all points are connected, where one interval ends is where the next one begins. We can use either the graph or our equation to evaluate our function. If we want to know how far Isaac was from home at a time of 1 hour, we could use the graph and see that he was 2 miles from home. If we were using our equation, we would find where 1 fits, in which interval 1 fits. 1 fits in this interval. It is between 0.5 and 2.5, so we know his distance is 2 miles from home. If we wanted to find out how far he was from home at a time of 3.5 hours, it's a little unclear using the graph, so we will find where 3.5 falls in the intervals. It falls in this final interval, and so we can substitute 3.5 in for t to find out how far he was from home. And we can see that he was 0.75 miles from home, or 3/4 of a mile. This is another example where you can see how we use point-slope form to create the expressions that make up the equation for this piecewise function. We start at -2, +6. The next piece starts at -1, -3. And the last piece starts at +5, +1. You may notice that where each interval ends, that is the x value of the next point that is used. We can also substitute the final x value in to the first expression or the previous expression to find out what the y value will equal. Because at each transition point, the x and y values work for both equations. So when x is 1, 1 plus 2 is 3, times -3 is -9, plus 6, and we see -3 here. When x is 5, 5 minus 1 is 4, minus 3 is +1. So there's a relationship, if you always use that first point, between the x and y values of your point-slope form. Finally, Note that piecewise functions can either be continuous or discrete. Discrete or non-continuous because you may have jumps and points where not all points are connected. Also note that you can have piecewise functions that are made up of non-linear pieces. You might have exponential pieces, quadratic pieces, anything that we can model using an equation, whether or not it's linear, could be part of a piecewise function.